Okay, so A2 is going to be similar to what we did yesterday. It is still graphing rational functions. Yesterday we did it in vertex form where you just shift left, right, up, down. Okay, so today we'll do it in a slightly different form. It's going to look more like the scenario where we have something on the top over something on the bottom. So I'll just say like g of x over h of x. Okay. So the textbook does not go over how you can find horizontal asymptotes. So I'm going to give you some quick, easy tricks of figuring out horizontal asymptotes when it's in this format. Okay, so horizontal asymptotes. There are basically 3 different cases. Okay, and I'm going to do this by example. Okay, case number 1 is, let's just say our f of x function is 2x squared plus 3x, and it's divided by 4x to the 5th plus 2. Okay, all you're going to be looking at is the biggest exponented term. Okay, so what is the biggest exponent to you on the top? Exponent 2. Okay, what is the biggest exponent that you see on the bottom? 5. Okay, which one is bigger? 5. Okay, so this is the case where the exponent is bigger on the bottom. Okay, so I'm going to say this is bigger on bottom. Okay, whenever the polynomial is bigger on the bottom, there is a horizontal asymptote always at y equals 0. Hayden, are you writing this down? Write it down. I can guarantee you won't remember this on your own. Okay, case number 2. Let's say you see something like 3x cubed plus 4x squared over 5x cubed plus 3. Okay, again, we are just looking at the exponents. Okay, is it bigger on the top or is it bigger on the bottom? They're the same. Okay, so I call this the same case. They're the same. Okay, and this one is very unique to the polynomial that is given. Okay, so this one has a horizontal asymptote, but I'm going to give this to you and see if you can figure out where I come up with this number. Okay, the horizontal asymptote for this one is at 3/5. Okay, yeah, you're exactly right. I am simply looking at the numbers that are in front of those x cubed pieces. Okay, that's all it is. I just stole those from the top and the bottom. Okay, good there? So what's my third case? The top is bigger. Exactly. Okay, so top is bigger. Let's just say we have negative 2x to the 4th minus 8 over x squared plus 9. Okay, so if it is bigger on the top, whoops, there happens to be no horizontal asymptote. No horizontal asymptote. But if it is a rational function, there is an asymptote, and in fact, there happens to be a slant asymptote. Okay, and there's a way you can actually come up with the slant asymptote. So instead of it being like horizontal and flat, it's bent upwards or downwards, depending on the function. Okay, so I'll show you what one of those looks like, so you can see an example. Okay, so what I'm going to do is I'm going to kind of pull these little examples that they have over here, because they're kind of good examples. I'm going to say example number 1. And I'm just going to kind of do my own thing with them. X plus 3, x minus 1. Okay, so what we are going to be doing is we're just simply graphing rational functions. Okay, this is all about graphing. Okay, so we know that a rational function has a horizontal asymptote and a vertical asymptote, right? So that's the very first thing that we need to figure out. Okay, so since we just talked about horizontal asymptotes, let's figure out where the horizontal asymptote is. So which case is this?
Same.
Is this bigger on the top, bigger on the bottom, or same?
Same.
Same. So if it's the same, what's my horizontal asymptote?
1.
Very good. Everybody okay with that? Y is equal to, whoops, I just wrote 0. 1. Okay, so you're following the fact that they have the same, they're both x to the first, right? Okay, and the invisible number in front of both of these terms is a 1, so you have a 1 over 1, which is 1. Okay, so that's why we have a horizontal asymptote of 1. Okay, vertical asymptote. Does anybody know where the vertical asymptote is?
3.
Okay, good guess on the 3. It's not the 3. It comes from the bottom. It's not -1. It's actually +1. Okay, so vertical asymptotes come when you divide by the thing that you're not supposed to ever divide by. What's the one number you're not supposed to divide by? 0. You cannot divide by 0. It's against the law. Okay, so the one value that makes the denominator 0 is 1. And that's where the vertical asymptote exists. Okay, so you get it from the bottom. Okay, so this is giving me almost enough information to graph this. I'm going to graph this and then I'm going to show you on the calculator and see if you guys start to notice something. Okay, so I'm going to draw my horizontal asymptote at 1. And then I had a vertical one here. Okay, and I know what this is going to look like for the most part. What does it look like? You drew a whole bunch of them on the last assignment. Okay, apparently not Trey's. The hourglass. Okay, so the hourglass function. Okay, so let me pull this up. Let me graph it into my calculator. Okay, so I'm going to hit alpha y equals allows you to do a fraction, if you didn't know that already. Okay, so the top is x plus 3, and the bottom is x minus 1. All right, here we go. Here comes the hourglass. Okay, so you can visually see the vertical and horizontal asymptotes here. Okay, so if I was the vertical asymptote, you could see one there and one there. Okay, I will tell you there's a very easy 2 points that we can come up with. Where does it cross the x-axis? It is -3. How did you guess that? Was this just a lucky guess? Ah, okay, so you used your function, right? You used the function, is that where you came up with the 3?
Well, I saw like the top was like 3, but then it kind of just looked like
The 3, yeah. Okay, so it crossed at -3. Okay, so very simply, if you set the top equal to 0, that gives you X-intercepts. Maybe write that down in your notes. X-intercepts are found by setting the top equal to 0. Top equal to 0. So, anybody know how I find the y-intercept? Good guess, but no. That's how you get vertical asymptote, silly. It does look like it is the same. It looks like about -3. Okay, think about the y-axis. If I ask you for any function, what if I said, okay, it intercepts way up here, it's on the y-axis, what definitely do you know about something that's on the y-axis?
X equals 0.
The x is equal to 0.
So trace that.
Okay, so we can go back to the function and just put an x into, or a 0 into both of my x's. And we can probably do this mentally, I assume, yes? 0 plus 3 is 3, and 0 minus 1 is -1. So 3 divided by -1 is -3. Okay. So maybe a little hint in your notes. How do you find the y-intercept? Plug 0 into the x. Okay, so those are a couple more points that can make me be a little bit more accurate when I'm drawing this. So I can plot those 2 points. And then draw my little hourglass. Pretty easy. Good enough for now? Let's try another one. All right, so the other one they give to me up here, oh, I like this form. Let's see, they say my function is x plus 5 times x minus 1 over x plus 1. Okay. All right, now this one looks a little bit different. Okay. First of all, if I'm going to find my horizontal asymptotes, okay, there's kind of a problem with the way that this is written right now, because right now the top is written in factored form. Okay, so we can FOIL it, and we don't even have to actually FOIL it because I only need to think about the very first term. We can do this mentally. If I was going to FOIL this and just multiply the first 2 x's together, what's going to be the top? X squared. Okay, so if I have x squared over x, which case is that for my horizontal asymptote? Bigger on top, so where is my horizontal asymptote?
0.
No.
There is no one.
There is no horizontal, and there's a slant asymptote. Okay, so on your paper, I would like for you to say no horizontal asymptote, but there is a slant, okay? Because there is this vertically, well, it's not vertical, slanted one. Okay, vertical asymptote. We can find a vertical asymptote here. What is my vertical asymptote?
-5.
No. Where am I looking for vertical asymptotes? Remember, those are the things that cannot do. You can't divide by 0. So what value makes the denominator 0? -1. We have a vertical asymptote at x equals -1. Okay, let's talk about x-intercepts. How do I find my x-intercepts? The top. Okay, so if I set the 2 quantities equal to 0, I have 2 x-intercepts this time. What are my 2 x-intercepts? -5 and +1. Good. Everybody okay with that? Okay. And last, my y-intercept. What do I do to find my y-intercept?
-5.
Okay, so plug 0 into the x. Let's see. So if I plug 0 in here, I would have 0 plus 5. So 5. 0 minus 1 is -1. So what's 5 times -1? -5. On the bottom, 0 plus 1 is 1. So I have -5 over 1. So -5. Good, I agree with that. Okay, so that is the information that I expect for you to be able to come up with on your own. Okay, and you should be able to obviously plot those things. Okay, so we have a vertical asymptote at -1. I do not expect you to figure out exactly where the slant is. There is a way to figure it out. We're not going to go over it. So we have x-intercepts at -5. 2, 3, 4, 5. One at 1. A y-intercept at -5. 1, 2. Okay, so now at this point, you get your calculator out, you plug it in, and you get to use your calculator to figure out what this looks like. Okay, by the way, how many of you guys have Desmos on your phones? Okay, I highly recommend using Desmos. Not that the calculators are bad, but Desmos is super easy to use. So if you don't have that on your phone, put it on your phone so you have it. You will want to have it at some point. Okay. So we should see the function split apart. Okay. So do you see the slant asymptote? Okay, so the slant asymptote is right there. See it? the slant. Okay, so it's separating that function. This side is going to get close to that line, and then this side over here is going to get close to it. Okay, so we're just going to transfer that onto my graph here. That looks good enough for that. Good there? We got one more example and then we'll be done. Okay? One more. Last one. All right, so I'm going to use this bottom one. We got 2x squared minus 3x plus 9 over x squared minus x minus 6. There we go. There we go. Okay, so this one is definitely in a form that you would definitely see at some point through your mathematical careers. You have a standard form over a standard form. Okay, we're going to start with the easy one. We're going to start with the horizontal asymptote. Okay, so which case is this? Bigger on top, bigger on bottom, or same? So where is my horizontal asymptote? Yeah, 2. 2 over 1 is 2. Okay, so that's good. Okay, next, I want to think about vertical asymptotes. Okay, so anything that makes my denominator 0 is going to be a vertical asymptote. So the next thing that I want to do is I want to start factoring. Okay, finding x-intercepts on the top, I want everything in factored form, and finding vertical asymptotes on the bottom, I want things in factored form. Okay, so what I'm going to do is I'm going to factor. Okay, so on the top, what method am I going to use in order to factor that? The box method. You guys remember box method?
Yeah, 6 is last. You can use 6 and 3, -6.
Okay, good. Okay, so we got 2x squared and 9. So we multiply the 2 and the 9, and you get 18. And you say, what two numbers multiply to 18 and add to -3? And you guys already figured out it was what? -6 and +3. Good. And make sure that you include the x. Now we're going to pull greatest common factor. What's the greatest common factor on the top row? 2x. What about the bottom row? 3. First vertical?
X.
Second vertical?
-3.
-3. Good. All right, so that means that this top is actually the same as 2x plus 3 and x minus 3. Okay, on the bottom. We can use easy method on this one. What two numbers? Oh, sorry, I want to add this, put this a plus right here. I'm going to change it just slightly. Adding a plus, I accidentally wrote that down wrong. Everybody okay? Plus. Okay, so what two numbers multiply to -6 and add to +1?
-3 and 2.
Close.
-2, 3 and -2.
Pot.
-3 and
-3 and -2.
Perfect.
Or it was negative.
It was, you're right. I did trick you. Okay. All right, so vertical asymptotes. How many vertical asymptotes do I have? 2. There's 2 quantities on the bottom. So where are the 2 vertical asymptotes?
-3 and 12.
Very good. Okay. On the top, I'm going to use the top to find my x-intercepts. Okay, so if I set the top 2 quantities equal to 0, what are my 2 x-intercepts? Can you do that mentally to set that equal to 0? Close. -3/2. And what about this one? +3. Everybody okay with doing that mentally? Okay. Minusing 3 divided by 2. Okay, y-intercept. Let's see if we can do this one mentally. Put 0 into the x's. My opinion, go back to this one. Go back to standard form, because if you put 0, 0, those two go away. On the top you have 9, 0, 0. On the bottom you have -6, so it's 9 over -6 reduced to 3/2. So y equals -3. Yep. Y equals -3/2. All right, so here we go. We go to graph this. We're going to plot the information that I have. I have a horizontal asymptote up 2 units. I have 2 vertical asymptotes, one at -3, one at +2. I have 2 X-Intercepts. I have one at -3/2, right about there, one at +3, and a Y-intercept at -3/2.
Wait, for the Y-intercept, you plug 0 in for all X's?
Yep. Yes.
Is it going to the ground or on? No. That was bad.
Alright, so I have 2x² minus 3x plus 9 x² plus x minus 6. Are we good? You guys following me?
Yes.
Okay, now check out what happens with this graph. What happened? Okay, we no longer have an hourglass shape. Once you have more than one vertical asymptote, it starts splitting the function. So if I have 2 vertical asymptotes, that means I have like 3 different pieces of the function. If I had 7 vertical asymptotes, how many pieces of the function would I have?
8.
8, one more than that. It splits the function apart. Okay. So you basically would need an aid of a calculator to come to, let's see if I can make sure I draw that right. Wait a second. Did I type that in right? Because I don't have any X-intercepts. What happened there? I must have typed that in wrong.
Yeah.
Okay, what happened?
No.
Because this went like this. I didn't have any X-intercepts. Did we factor wrong? This is not showing my intercepts. Oh, I do see. We did factor wrong. Did you guys see this? Oh my goodness.
3.
It says
6 times 3 is 18.
6 times 3 is 18.
said
Oh.
-6 and 3.
Yeah. So this is kind of a weird case with the box. We didn't screw up our box at all. But what happened is when we pulled it out, it didn't work right. Because look at this. If you were going to FOIL this, just look at the very last term. What's 3 times -3? -9, right? That doesn't work. So this is not factorable at all. Oh, that was cool how that erased. Let's do that. Okay, so we actually have no X-intercepts. None. That was not factorable. Okay, so make sure that your graph matches the pieces of information that you have. That was a good example to show that, huh? Okay, are we good? No?